In this video, we're going to focus on integrating tangent to the fifth power of x dx. How can we find the antiderivative of that expression? When dealing with tangents, typically it's helpful to take out a tangent squared. 5 minus 2 is 3, so we're going to have tangent cubed times tangent squared. And the reason why you want to take out a tangent squared is because tangent squared is part of a trigonometric identity, also known as the Pythagorean identity. Perhaps you know that 1 plus tangent squared is equal to secant squared. So if you subtract both sides by 1, you can see that tan squared is going to be secant squared minus 1. So let's go ahead and replace tangent squared with secant squared minus 1. And so this will give us the integral of tangent to the third power times secant squared minus 1. So what we're going to do at this point is we're going to distribute tangent cubed to secant squared and to negative 1, and we're going to split the integral into two separate integrals at the same time. So we're going to have the integral of tangent cubed secant squared dx minus the integral of tangent cubed times negative 1. So I already have the negative sign on the outside. So that's just going to be minus integral of tangent cubed dx. Now, for tangent cubed, we can take out another tangent squared and repeat the process. So it's going to be tangent times tangent squared x. And then let's replace tan squared with secant squared minus 1. Now we're going to distribute tangent to secant squared and negative 1 and break that into two more integrals. So the first integral is going to be the same, and then the second integral is going to be tangent secant squared with a negative sign in front. So we have minus integral of tangent x secant squared dx, and then the last integral will be tangent times negative 1, so that's negative tan, and we have a negative in front of it, so that's going to be positive integral tangent x dx. Now we're going to use u-substitution for all three of these integrals, but for the first two, the u-substitution will be the same, so to speak. So I'm going to make u equal to tangent x, so that du will be equal to secant squared x dx. So I can replace tangent with the u variable, and I can do that here as well. And then I'm going to replace secant squared dx with du. So I can integrate two integrals at the same time using u-substitution. So this is going to be the integral of u to the third du minus the integral of u du. And I'll get back to that later. Now, let's focus on tangent. So tangent, I'm going to write that as sine x over cosine x. And I'm going to use u substitution, but let's use a different letter than u. Let's use y. Let's say y is equal to cosine x. dy is going to be the derivative of cosine, that's negative sine x dx. So solving for dx is going to be dy over negative sine x. So sine x, I'm going to just rewrite it for now. Cosine, we said it's y. dx is dy over negative sine. So we have negative integral 1 over y dy, which will give us negative natural log of y plus c. And then y is cosine, so this becomes negative ln cosine of x. And then we need to distribute the negative 1 sign to cosine. So it's ln cosine x to the minus 1, which is the same as ln 1 over cosine. And 1 over cosine is secant, so this is ln secant of x. So we can replace the integral of tangent x with the natural log of secant x, and then plus some constant c. So we don't need this anymore. Now let's get back to what we're dealing with here. The integral of u to the third is going to be u to the fourth over 4. And the integral of u is u squared over 2. And then we already have ln secant x plus c. Now, let's replace u with tangent. So the final answer is going to be 1/4 tangent to the 4th power minus 1/2 tangent squared plus the natural log of secant x plus c. And that's it for this integral. Thanks for watching.